Now we are looking at Chapter 2, which is Science, Matter, Energy, and System. If you look at the whole content, you will realize that Chapter 2 is here. So Chapter 2 is the beginning of the 7 chapters we're going to review or learn foundations of science, scientific principles. Chapter 2, we will look at the core case study and then 4 sections. This video would cover section 1 and part of section 2. I love the following quotations about science, so I put it here for you to enjoy. The first one, science is built up of facts, as a house is built of stones. But an accumulation of facts is no more a science than a heap of stones is a house. I really like this quotation. So what this one tells you about is you cannot just accumulate your knowledge, definition, concepts without knowing their structure, without knowing which concept serve which idea, and then which one is evidence, which one support this or develop another model. So we needed to know the functions of each piece of science you learn. And then the second and the third quotations just goes together. Okay? If nature were not beautiful, it would not be worth knowing. And if nature were not worth knowing, life would not be worth living. The scientist does not study nature because it is useful. He studies it because he delights in it. And he delights in it because it is beautiful. I hope after your own natural walk, you would agree with those quotations. Let's look at the core case study. This one is a study of forest. It is called Hubbard Brook Experimental Forest somewhere in New Hampshire. So this one compared to site. So this one is the experimental group with a lot of clear cut down of the trees, and then this part is the uncut area as a control. So they compare the loss of water and nutrients from an uncut forest, the control site, with one that had been stripped, experimental group, and then the clear cutting. So what they found out is the stripped site has a 30 to 40% more runoff than the other. And then also the cut site has more soil erosion, more nutrient runoff altogether. So section 1, we are going to quickly review scientific method. I will go relatively quickly, okay? So what scientists do? Scientists collect data and develop hypotheses, theories, models, and laws about how nature works. The steps in scientific method, including several, you guys, I think you're pretty much familiar with that. So I just read it through. You needed to identify a problem, find out what is known about the problem, ask a question to investigate, perform an experiment, collect data, and analyze data to answer the question. And then you propose a scientific hypothesis to explain the data, what you have seen, for your further research. And then you use your hypothesis to make projections, which means predictions. And then you test them again. And then if your hypothesis is supported, that's good. If they are not, you revise your hypothesis. And then after many of the research, if you have a very well tested and then widely accepted hypothesis, this one become a theory. So those are the steps of the scientific research. And then during this process, some characteristics are the scientists need to be full of curiosity, skepticism, and then producibility, and then peer review. So one term you needed to know is peer review, which means your work would be reviewed by other scientists before you get published, get accepted. And then one confusion frequently students have is the difference between theory and law. So an easy way for you to know is look at the theory. Theory meant to explain something. So explain what the phenomena you see. However, a scientific law is simply describe what you see. You describe, say, once the apple fell from the tree, it will fall to the ground, not fly. So this is a law. No matter where you go and how many times you observe, it always happens. So this is a law. However, if you start to try to explain it, use Newton's gravitational law, and then you become explanation. So scientific theory means you explain something, and then the law is simply you describe what happens. And then some other terms might be new to you is tentative science or frontier science. So do not think those are nonsense or those are made by people just with a hobby. So frontier science is real science. However, they have not been fully checked, repeatedly checked. So if they found something very new, the New York Times might report them. However, they have not been confirmed. So frontier science later on may be confirmed or may be denied. And then reliable science are those you see in a textbook. They have been widely tested and accepted. And the unreliable science, those are science has not been fully go through peer review by the expert of your fields. So those could be not real. Recently, sometimes we hear the report of unreliable science. And although we know science is very powerful, we also wanted to know their limitations. One, scientists cannot prove or disprove anything absolutely because new evidence keep coming. Second one, scientists are human beings, thus not totally free from a bias about their own hypotheses and results. Three, systems in the natural world involve a huge number of variables and complex interactions. So if new discovery being released, they could challenge the conclusions we made before. Number four, science involves the use of statistical tools, which means estimation is involved. If estimation involved, human judgment, human bias also involved. Okay, we will go through some part of section 2, but I don't think this video is able to cover all of them. Okay, so 2 is important. What is matter and what happens when it undergoes change? So the big concept is matter consists of elements and compounds, which are in turn made up of atoms, ions, or molecules. The second part is whenever matter undergoes a physical or chemical change, no atoms are created or destroyed. This one is called the law of conservation of matter. So this part is mainly a review, but several terms are critical. You need to know, okay? So we all know matter is anything has mass and takes up space. So one typical term we use is elements. Those are the elements you see in a chemical periodic table. So elements have unique properties, and they cannot be broken down chemically into other substances. Compounds, they are two or more different elements bounded together in the fixed proportions. For example, when you think about water molecules, H2O, this one is a compound because you have two different elements, hydrogen and oxygen. And then their proportion is fixed. It's 2 hydrogen atoms with 1 oxygen atoms. If this proportion changes, it is not water anymore. So 2 or more different elements bounded together in fixed proportions. Molecules is a combination of 2 or more atoms. Those atoms can be the same atoms. They can be different, also held together by chemical bonds. So for example, oxygen, O2, is a molecule. It's not a compound. However, water, H2O, is a compound and also a molecule. So in the quiz, you need to read the questions carefully, distinguish between compounds and molecule. Okay, these are examples of element, gold and mercury. Here are the symbols and names of several elements frequently we use in environmental science. You do not need to memorize those right now. You would not see a particular question in the quiz or test ask you the symbol. However, gradually you should spend time, pay attention to know those symbols and names. And then let's start to look at atoms. So atoms, molecules, and ions, they are building blocks of matter, of bigger molecules. So atomic theory is proposed by John Dalton, says all elements are made of atoms. And then later on, we discovered subatomic particles. Nucleus of the atom, inside you have protons with a positive charge and the neutrons with no charge. And then outside of the nucleus, you would see negatively charged neutrons, the orbit around the nucleus. And then whenever you hear atomic number, these are number of protons in nucleus. And then mass number means number of protons plus neutrons in nucleus. So this is a model of carbon. 6 protons and 6 neutrons inside of the nucleus, and then around it you have 6 electrons moving around. Isotopes, they are the same element, different number of neutrons. Thus, you would have different mass number too. And the ions are atoms of an atom or a group of atoms with 1 or more net positive or negative charge. And the acidity, we measure it with pH, which means the concentration of hydrogen ions. So here is the ions. We use it often in environmental science. Again, you do not need to memorize for now, but you should spend time frequently look at them. So I'm going to start this slide for next video. So I'm going to stop here. Thank you.